All right, so we're going to talk about absolute value inequalities. Okay. Absolute value inequalities, they bring us into using compound inequalities. Remember, we talked about those yesterday. And so the compound inequalities is going to be the working force in doing absolute value inequalities. So kind of see as we're going along here, everything we do kind of builds to the next thing here. Is that very rarely does one thing just kind of set alone in an algebra class. It's usually step-by-step kind of stuff. So the compound inequalities that we talked about yesterday with the and the or problems are how we're going to work absolute value inequalities. You've done these before. You may have been a while. Like I said, if you had year-long Algebra 1, this was done in the fall of your freshman year. So it's been a while. And you don't do this very much in geometry. So it's one of those things where you're going to be rusty at it maybe. But through the practice we've done this week and last week, I think you're going to be okay. So I have this little saying that I use to help you know which compound inequality to use. And my saying is this: the land of Gore. In the land of Gore, less than is an and problem. Greater than is an or problem. Okay. For this little saying to work, your absolute value has got to be on the left. And most of the ones you're going to get presented in this course, and for the most part, almost all your algebra classes in high school for sure, the absolute value is going to be on the left anyway. But the absolute value's got to be on the left, and if it is, you can look at the inequality symbol. If it's a less than, remember that's this sign or the less than or equal to sign. Remember, it's that one. That's the less than symbol. Then you're gonna treat it like an and problem. If it's a greater than, you're going to treat it like an or problem. And the reason that you're doing that is because what is absolute value? What's its definition? Distance away from zero. So if the absolute value, distance away from zero, is less than a number, then where's it going to go? Toward the middle, right? Toward zero, right? Because if the distance away from zero is getting smaller, less than, it's going to go in the middle. So and problems, where were the answers in the middle when we graphed those? Or with and problems, the answers were in the middle, right? So with or problems, it's greater than is an or problem because if the distance away from zero is greater than a number, if it starts here and it's getting bigger, it's going away from zero, right? And or problems, the graph went away from zero or away from the center out of that. So that's the idea. That's the reason that this saying works out of that. So we're going to, first thing that we have to decide on a problem before we set up anything to solve it is it an and or an or problem? And once we know that, that tells us how to set it up. Okay, so let's look at some examples and do those things. So the first example, we'll start real easy. X plus 6 in absolute value is greater than 7. So before you do anything, just look at that and see, is the absolute value by itself? Yes. Okay, so just like with the equations that we did the other day, absolute value has to be by itself first before you decide anything about no solution or anything like that. So with inequalities, it's got to be by itself before you decide and or. So this is by itself. What symbol is between that and the number? That's a greater than symbol. So this is going to be what kind of problem? An or problem. How were or problems written yesterday? With the word or in the middle, right? All right, so the way you're going to set them up is you're going to just take the absolute values off. x plus 6 is greater than 7, or x plus 6, and then we're going to flip the symbol and change the sign. Flip the symbol, change the sign. And then we just solve both of those separately. Okay? Easy enough. Subtract 6. X is greater than 1, or x is less than negative 13.